Good day, class. Let's start off with a quick review of where we've been and a preview of where we're going in this particular session. So far in this first chapter of psychology, we look at the history of psychology, looking at where it started, where it began. We also examined what psychology developed into a separate academic discipline in 1879, looked at the early schools of thought, such as structuralism and functionalism. We then examined somewhat, to a certain degree, the diversity issues in the early days of psychology, particularly as it results when it comes to women. Women in psychology. We have several key figures that were very heavily involved in the early schools of psychology, but they were not necessarily treated with respect and treated well, particularly if they would complete everything required for a PhD degree, but they would not confer that degree because they were women. We then examined some of the major forces in psychology. These are a little bit more than schools of thought. Behaviorism, particularly in America, became a major movement. It had a great deal of influence on the direction and caliber of psychology during that particular time frame. We also examined Freudian psychology, which also had a great deal of influence and was a major force. Both behaviorism and Freudian psychology had somewhat negative connotations, according to some. That's where we get the third major force in psychology, humanism, or the humanistic psychology movement, where they thought that the negative connotations of behaviorism, meaning that we did not have free will over ourselves, or that the unconscious ruling our behavior from the Freudian perspective, was way too much. Therefore, they developed a different perspective of psychology that was much more in tone with the notion of human beings having free will and were being quite capable. Then we looked at contemporary psychology, such things as evolutionary psychology, such ideas as nature versus nurture questions, natural selection, behavior genetics, and so on. Then we examined briefly the levels of analysis. Basically, the idea that anything that we look at in this course, any phenomena or of psychology or behavior or process, can be looked at by way of its biological factors that influence it, the psychological factors, and the social cultural factors that influence it. Then we discussed the subfields of psychology, looking at two areas of research. Basic research, where we're studying items just to get the knowledge. We don't have anything in mind, we just want to know something. And applied psychology, where there is a particular solution that we're looking for a particular problem. So basic and applied research. Then we looked at professional psychology, where these are people who are doing certain types of jobs to complete certain types of tasks, be they clinical psychologists, counseling psychologists, what have you. Then the last bit that we looked at and where we left off was the scientific method. We examined case studies, naturalistic observation, and in this session we'll be examining surveys and interviews, correlations, experiments, and then looking at the psychology and ethics within psychology. So let's look at this other area that helps us to describe in psychology. The method used here is surveys and interviews. Simply, and most of you have some idea of what we mean here, people ask questions. They ask people to self-report on their behavior or opinions of a particular group. So they get a group of individuals that they have interest in, and they ask them some questions about their thoughts to this, that, and the other thing. Now, it should be noted that surveys and interviews are not without their issues or potential problems. They're going to be wording effects, meaning the way you word your survey items may cause issues when it comes to the results. There's also issues dealing with sampling. Sampling should be a representative sample or random sample in the population. What we mean here is that when we're asking surveys of individuals, we're not really interested in the 1,000 individuals that we're asking. We're interested in what the opinions are of the hundreds of millions of people that sample may represent. Let's go ahead and cover a couple of key ideas here. We have the random sample. A random sample is a sample that fairly represents a population because each member has an equal chance of inclusion. So we're not arbitrarily picking people. It's a random sample, meaning everyone within that population had the possibility of being included in that sample. And what is the population? A population is all those in a group being studied, from which samples may be drawn. Today, we're entering into a political season, and you'll see a lot of survey results popping up in the next few weeks and months. The idea is that they're sampling from a larger population, and when they ask questions of that smaller sample, they're going to try to generalize those results to the larger population. So, best basis for generalizing is using a representative sample. So, if you have a population, for example, that has a 12% minority, if you're trying to generate a sample that's going to be representative of that larger population, that sample should include 12% minority in that sample. An unrepresentative sample cannot be compensated for by simply adding more people. If your sample is not representative of the larger population, the results cannot be generalized. So what we mean by generalizing results is simple. If you want to find out if the population thinks a certain idea makes sense, you get a small sample of that population that's representative, random sample, but representative sample, and you ask those 1,000 people about their thoughts to that particular course of action. And then you can generalize the results to the hundreds of millions of people in the country. Believe it or not, that actually does work if everything is done properly. But not all the time do we see things done properly when we're seeing survey items being developed. Here are a few examples of when they don't actually work out so well. I got some of these examples from surveytown.com, and the link is listed there. So if you want to go to it yourself, you can do so. Here's an example of a leading question. One of the biggest mistakes survey creators make is creating a question that leads respondents to give the, quote, correct answer. Leading questions negate your survey results, meaning that they throw the results out the window. Your survey is not going to be telling you the truth. So you want to stay away from them at all costs. You don't want to word a survey question in a way that will sway your reader to a particular side. To do this, you must use neutral wording. Here are some examples of leading and biased questions. A leading question such as this: how dumb is insert politician when it comes to foreign policy? This immediately brings a negative connotation to the question. Instead, you might ask the question like this: please describe your politician's position on foreign policy. Very neutral. Another example of a leading question is this: should concerned dog owners vaccinate their pets? By using the word concerned, you put pet owners who don't vaccinate their pets on the defensive, thus creating bias. Instead, ask this way: do you think dogs should be required to be vaccinated? So that's one type of wording effect that we can see when we come up with surveys. A couple of others. The loaded question. With the loaded question, you basically force people into answering the question in a particular way. You keep them from explaining their own opinions. The loaded question has the potential to lead to survey dropout and unclear results. Survey dropout, meaning that people just don't finish the survey. And the results obtained from loaded questioning surveys will be somewhat problematic. So here's an example. Where do you like to party? Well, what if the respondents don't like to party? What if they are homebodies? Instead, you can ask like this: what do you like to do on weekend evenings? You avoid loaded questions so you get the most truthful survey answers. And here's one of my favorites: the double-barreled question. Another very common survey mistake. You'll easily destroy your survey results with the double-barreled question. You want each one of your survey questions to only answer one thing. One subject per question is the rule for accurate, measurable surveys. Here's an example of double-barreled. How happy or unhappy are you with the rate of current school board funding and the Common Core curriculum? Wow, this is asking a lot of your respondents. Some might answer both questions, but many others will concentrate on the one that means the most to them. Instead, you could ask it like this: How happy or unhappy are you with the rate of current school board funding? That's one question. Then in the next question, what do you think of the Common Core curriculum here? That's another question. Always break questions into singles so your survey is succinct and measurable. And sometimes, just to give you another example of how bad these things can be, let me give you an extreme example. Let's say somebody was responding to a survey, and the survey response is either a yes or a no. Well, have you stopped beating your dog? If you respond yes to that survey item, that means you at one time did beat your dog. If you respond no to that survey item, that means you are still beating your dog. So oftentimes there are no real correct answers. The survey creators of that particular really bad item have something already in mind. They want to present results that people are beating their dogs. All right, let's move on. The other item that we want to cover is the correlation. Correlation is a measure of the extent to which two factors vary together, how well the factors predict each other. Usually explains only part of the variation among individuals. It uncovers naturally occurring relationships. So what we're saying here is that sometimes we see one thing, and if we see one thing, we normally see that other thing too. That tends to suggest that they are correlated. All right. So we're looking at two variables and how they are related to one another. Now, a key concept involved here is the correlation coefficient, a statistical index of the relationship between two things. A positive correlation is greater than 0 to positive 1. It indicates a direct relationship. A negative correlation is less than 0 to negative 1, indicates an inverse or negative relationship. We're not talking about positive as in good or negative as in bad here. We're just talking about what type of relationship is being present. Here's some graphs that may clarify a little bit. The upper graph sort of illustrates what we mean here. So we have these scatter plots. And a positive correlation basically means as one item goes up, so does the other item goes up. So as your height increases, normally your weight also increases. That's telling you the type of relationship, a positive one. Look at the graph in the middle. It's a flat line. And all the dots there, the data points, are sort of spread around that straight line, almost like a big O or 0. That represents no correlation. Now let's slide back to the graph we just already covered on the far left here, the positive correlation. You see how they're not around like an O. They tend to be sort of anchoring themselves around that blue arrow. That shows a positive correlation. The line tends to go up. Okay, so as one goes up, so does the other go up. The one in the middle, no correlation. The one on the far right, a negative correlation. As one goes up, the other one goes down. So you can see here, it has the same cluster of data points around the arrow. So the very first one, the positive correlation, as we can see in the correlation coefficient of 0.4, is a positive 0.4, saying the relationship is a 0.4 between the variables, the two variables. In the middle, we have a correlation coefficient of 0, meaning there is no relationship between the variables. And the one at the very end here, the negative one, the correlation coefficient is a negative 0.4. Okay, meaning that there is a negative relationship. As one variable goes up, the other variable goes down. So let's think about this real quickly. Let me give you an example. Let's say we're doing an accuracy test on a driving course when people are drinking alcohol in controlled conditions. The more alcohol they drink, the less accurate they become on the course, the driving course, controlled driving course. So that means as more alcoholic drinks are consumed, their accuracy goes down. That demonstrates a negative correlation. As one variable goes up, the other variable goes down. A positive correlation would be this. The more milkshakes you drink during a summer vacation and all the other treats you have, the more your weight goes up. That represents a positive correlation. The more sweets and desserts you drink and consume, the weight goes up, a positive correlation. Now, with a 0.4 or negative 0.4, we can look at the other graph I have down here at the bottom right. It shows the strength and direction of correlation. So I just want to give you an idea here. Anything that's a 1, positive or negative, that is a perfect correlation. Very, very strong. 0.8, 0.9, whether it's positive or negative, is also quite strong. 0.5 is more of a middling correlation. Okay, so we see here weak to strong, just to give you a basic idea of how this actually works. Okay, all right, so correlation does not prove causation. Correlation suggests a possible cause and effect relationship, but it does not prove it. Remember this principle and you'll be wiser as you read and hear news of scientific studies. Simply because things are correlated does not mean that one thing in that correlation causes another, because there are other variables. Remember, a correlation is only looking at 2 variables. All right, let me think of a really crazy one here. For example, let's say you just purchased yourself a house, okay? A house with a lot of square footage. And you read recently that there's a strong correlation between the number or square footage of a home and the level of expense, how expensive your car is. Now, if you believe correlation is causation, the following scenario would be a logical step. So you purchase your home. Your first night in your home, you haven't even got the stuff furnished yet, so you're sleeping on a mattress on the floor in your upper bedroom of this 6,000 square foot home. You wake up the next day, you stretch, you go to the window, you look down to your fancy driveway, and then there is a new Lexus in your driveway. The idea here would be this. Because you purchased a home with enormous square footage, it caused that car to miraculously appear in your driveway. That would indicate a cause-effect relationship, but we know that is nonsense because there's another variable between square footage of your home and the expensiveness of your car, and that is income or money. And that's the issue when it comes to correlation proving causation. It can't, because you don't know all the variables. You don't have all the information. But there is something that does help us determine causation, and that is experimentation. Experiments enable researchers to isolate the effects of one or more factors. Okay? By doing that, when there is a change in something, we can sort of hone in on what caused that change. All right? So, in an experiment, we manipulate the factor of interest to determine its effect. We hold constant other factors. Experiments oftentimes are about control. We try to remove everything that can possibly influence the factors that we're interested in, and then manipulate and change only one factor. And then if there's a change in the results, that change has to be because of that factor that we manipulated. So let's look at some of the groups when it comes to experimentation. We have the experimental group that receives the treatment. We have the control group that does not receive the treatment. There's random sampling. Create a representative survey sample. So everyone has an equal chance of being in the population, either the control group or the experimental group. Random assignment equalizes the experimental and control groups. So you have a population, you subtract a group from the population as a sample, and then you randomly assign to one of 2 groups. The experimental group that receives the treatment and the control group that does not receive the treatment. This random assignment equalizes the 2 groups, so they start off the same. Random assignment almost sounds like magic. because through random assignment, you can ensure that your groups are basically going to be equivalent to each other. The experimental group is going to be equivalent to the control group. Let's look at this a little bit more closely here. All right, so we now have this procedures and placebo effect. We'll get more back to the experimental groups in a second here. We should have an example of that. All right, so we have the double-blind procedure and the placebo effect. So experimental procedure in which both the researcher participants and the research staff are ignorant about whether the research participants have received the treatment or placebo. Now let me explain this a little bit better here. So when we have an experiment, we have the experimental group that receives the treatment and the control group that does not. Normally, in a simple experiment where we have a blind procedure, not a double blind, but a blind procedure, the experimenter knows what condition the participant's in. They know whether or not this participant is in the experimental group and receiving the treatment, or this person is in the control group and not receiving the condition. Let me give you a medical example. This may be a little bit clearer. There's something referred to as clinical trials when we're looking at medicine studies. They want to test treatments of certain medicine to see how they work, and they can develop protocols and develop the idea of what the side effects of the medicines are. All right. So in a blind procedure, that means the research staff is fully aware as to who's receiving the treatment and who's receiving not the current treatment. In a double-blind procedure, that's not so. In a double-blind procedure, not only is the participant not aware of whether or not they're receiving the treatment or not, the staff who is completing the injections or establishing the IVs for the patients, they're not aware either. They're blind and ignorant of whether or not the person who's receiving the injection is getting the treatment or a placebo. And again, what a placebo is this. A placebo is a fake something. You're not getting anything that has any real active ingredients in it. So they need to do studies like this and clinical trials for medicine in order to make sure that they have evidence of the true results of the study, not what people expect or feel. Now, the placebo effect is just that. Experimental results caused by expectations alone. Any effect on behavior caused by the administration of an inert substance or condition which the recipient assumes is an active agent. What this basically means is this. Sometimes you can give somebody a pill and tell them it will have such and such effect on you. They take the pill and they will start to experience the effects, even though the pill could not be what they thought it was. It could be just a sugar pill. Totally inert, will not cause any type of issue in the person whatsoever. Let me give you another example of the placebo effect. Let's say I have a friend who just turns 21 years of age, and I take him to a bar for the very first time for some drinks, legal drinks. And I tell the bartender, he's 21 years old now, please bring him as many Shirley Temples as he can drink. And so my friend begins to drink Shirley Temple after Shirley Temple. And then he gets up and says, I have to go to the restroom, and he stumbles away from the bar stool into the restroom area. Okay, he comes back. Man, I might be drinking too much, he says. I feel a little bit woozy. The problem behind all this is this. If anyone is aware, a Shirley Temple is a non-alcoholic drink disguised to taste like it does have alcohol in it, but it has nothing in it. It is totally non-alcoholic. But if a person drinks 5 or so Shirley Temples and they say they feel a little bit woozy, it's the placebo effect. They believe that this substance that they are ingesting should have an effect on them, and because of that expectation, it does have an effect on them. So we need to make sure that experiments that we are doing are not placebo effects, and we use this to make sure that not only does the patient not know, or the subject not know, or the participant doesn't know, but the researcher doesn't know as well. Okay, now, experiments. Let's get a little bit more in detail with experimentation here. There's a couple of ideas. We have something called the independent variable. Is an experiment. This is what is being manipulated, the independent variable. We manipulate the independent variable to see what effect it has on the dependent variable. Okay? The idea here is that if we give you one condition of the independent variable, it will have an impact on the thing that we're measuring, the dependent variable. A confounding variable is a factor that might influence the study's results. We're not usually aware of that. We try to control for as much things as we possibly can in an experiment. So let's look at this example. Hopefully it clarifies. So we are looking at seeing if breastfeeding versus non-breastfeeding has an impact on intelligence scores. All right, so here we go. So random assignment. Controlling for other confounding variables such as parental intelligence and environment. What this basically means is we are going to randomly assign children to one of two groups, the experimental group and control group. And what random assignment does here, it will control for confounding variables such as parental intelligence and environment, meaning how smart the parents are and what type of environment they were raised in. By random assignment, we should have, when we start this research, the experimental group and the control group should be equivalent to each other. Then we see breast milk versus formula milk. That's what we manipulate here. They're either going to be breastfed or going to use formula. All right? So once that is done, then later we're going to measure their intelligence scores. The notion here is by doing that, we are going to assume that the intelligence scores may be a result of the independent variable breastfed or formula fed. So the dependent variable is dependent upon the independent variable, how they were fed. That's the basic premise behind this. So to discern causation, psychologists control for confounding variables by randomly assigning some participants to an experimental group and others to the control group. Measuring the dependent variable intelligence test scores will determine the effect of the independent variable type of milk, formula versus breast milk. Now, just to clarify, a variable can be anything. A variable is anything that can vary. Infant nutrition, intelligence, TV exposure, along with the bounds of what is feasible and ethical, because we can't do everything here, obviously. Experiments aim to manipulate an independent variable and measure a dependent variable and control for confounding variables. So any experiment is trying to manipulate the independent variable, measure the dependent variable, and control for confounding variables. An experiment has at least two different conditions, an experimental condition and a comparison or a control condition. Random assignment works to minimize pre-existing differences between the groups before any treatment effects occur. In this way, an experiment tests the effect of at least one independent variable, what we manipulate, breast milk versus formula, on at least one dependent variable, the outcome we measure. And in this example, intelligence scores at age 8. So there are so many types of experiments out there, and they can be very complicated. But the key things here is that we manipulate an independent variable to see if it has an influence on the dependent variable by holding as many other confounding variables under control as much as possible. So, how would you know which research design to use? We want to develop testable questions. We select the most appropriate research design, be it experimental, correlational, or case study, naturalistic study, longitudinal, what have you. There are a variety of research methodologies out there, and it will depend on what types of questions you're trying to answer. We measure the behavior or mental process being studied, and then we interpret the results. That's the basic premise behind our research designs and how we do them. So just comparing what we've done so far. We've looked at the research method of the descriptive methodologies, And here the basic purpose is to observe and record behavior. How conducted? We do case studies or naturalistic observations, or we conduct surveys. Is anything being manipulated? Nothing's been manipulated here. There are some weaknesses. There are no control of variables. Single cases may be misleading. So we use descriptive just to get the scope of the landscape, so to speak. Then we move on to correlational studies. The basic purpose of correlational study is to detect naturally occurring relationships, to assess how well one variable predicts another. How do we conduct it? We can collect data on two or more variables. There is no manipulation whatsoever. The weakness of a correlational study is we cannot specify a cause and effect relationship. Then we have experimental methodology. The basic purpose of an experiment is to explore cause and effect. We manipulate one or more factors, and we do use random assignment. We manipulate the independent variable. There are some weaknesses, however. The weaknesses are sometimes it's not feasible to do experiments on everything. Sometimes there may be some ethical concerns that we would not do it simply because there's going to be something that would be immoral to do it. Results may not be able to be generalized to other populations. And again, there are certain types of things that ethically we cannot manipulate. For example, we want to know, for example, about nature versus nurture. One way to do that, if we did not have ethics, we simply go to hospitals and find out if they are mothers who are giving birth to twins. Let's say identical twins would be ideal. Then we take the twins from the mother. We put one in a certain home with a certain environment, and we put another in a different home with a totally different environment. And then we measure them later as they develop and grow to see what types of effects do we see the environment having on these individuals. The key thing here when it comes with identical twins is that the nature, the DNA, the genes are exactly the same for both those children. Okay, but obviously those are some major ethical concerns. We would never do that. But that would be able to get some clear idea about nature versus nurture and how they develop into an individual and what characteristics those nature and nurture influences individually. Okay, moving on. So basically, predicting everyday behavior. Experiments' goal is to test theoretical principles. The resulting principles, rather than any specific findings, help explain everyday behavior. So we're not looking for any specific behavior that we're trying to predict. We're trying to test theoretical principles, which may lead us to be able to predict how individuals may behave. Okay, this is the basic premise that we have for many things. For example, even in forensic psychology, and individuals who study serial killers, they study serial killers, they give them all sorts of surveys and personality tests with the idea of being able to test out their theories about how these people wound up the way they are and how they commit their crimes to be able to predict how some other serial killer may behave in the future. Psychological science focuses less on interpreting specific behaviors than on revealing general principles that help explain many behaviors. So it's not about specifics. It's about trying to understand general principles that help us to explain many behaviors, not just one behavior. Okay. Other things dealing with ethics. Ethics are important. These are guidelines to how it is that we should behave. Protecting animal research participants. Why study animals? To understand species differences and similarities and to investigate treatment of human diseases, we utilize animals quite a bit to use in psychological, biological, and medical research. We will see a little bit later in this course that a lot of the things that we have learned and learning, human learning, we learn from animals. And so we'll talk about that a little bit later. Key issues in protecting animals. Is it right to place the well-being of humans above that of other animals? That's a question for other classes. Which safeguards should protect animal well-being and research? The variety of organizations out there, including the APA, that have specific guidelines about how we use animals in research, even to the point of how animals should be euthanized or killed once the experiment has been conducted. They must be done so in the most humane way possible to limit the amount of harm and suffering any animal may go through. Now, there are also major ethical guidelines when it comes to humans, obviously. Protecting human research participants. I should also note that there are also very stringent ethical guidelines when it comes to clinical and counseling psychologists and dealing with their clients or their patients. With regard to making sure that there are no bounds that are stepped over and the relationships between client, patient, and therapist are proper. So, looking at the ethics code of APA, obtain potential participants' informed consent to take part in any type of research study. There needs to be permission, and you need to give them informed consent to give them some idea of what the experiment will involve. We need to protect participants from greater than usual harm and discomfort. We need to keep information about the individual participants confidential. And we need to fully debrief people, explaining the research afterward, including any temporary deception and things of that nature. Why we were lied to, for example. And sometimes they will be misled as to the purpose of the experiment. Every university and major research institution has a lot of things that it needs to do. And one of them, they have what is known as a institutional review board, which looks at all the proposals for all research, and it must be approved by the IRB before the research can be conducted. Now, we need to understand, too, one key factor about all research and researcher values. Researchers, psychologists, they are human beings, and what their values are will influence the topic choices they select to do the research on. It will color the facts of observations and interpretations. These things may be hidden or unconscious, but researchers are trained to try to understand what their biases may be in order to watch after them and watch out for them so they can try to avoid them in the future.